Plants talk to one another in languages we might soon translate. Steve Bate from The Conversation reports, "This morning my 6-year-old came into our bedroom and started reading a story from a book. She followed each word on the page, slowly forming full sentences. Sometimes she stumbled and asked for help with some funny words, but by the end of the book she had told us a story about a bear in the snow." Verbal communication is one of the many reasons why humans have become so successful as a species, from warning each other of danger to communicating complex information. Our ability to speak has been crucial, but it's not just humans and other animals who develop sophisticated communication. A lot of people think of plants as passive, but they have their own way of interacting with each other. The idea has been around for a while, even inspiring Hollywood movies like Avatar. But recent science is showing plant communication systems may be more complex than we imagined. These communication networks are sensitive and in balance. Imagine how disrupted our world would be if global network systems suddenly broke down. The recent CrowdStrike IT outages are just one example of how delicate these systems are and how important communication is, and that's the case for plants too. To grasp how organisms who can't speak pass on information to each other, it's important to understand humans also have a nonverbal communication system. This includes our sense of sight, smell, hearing, taste, and touch. For example, natural gas companies add a chemical called mercaptan to natural gas, giving it that distinctive rotten egg smell to warn us of leaks. Think also of how we have developed sign language while many people are skilled lip readers. In addition to these senses, we also have equilibrioception, the ability to maintain balance and body posture. Proprioception, the sense of relative position and strength of our bodies. Thermoception, sense of temperature changes. And nociception, the ability of sense pain, to sense our pain. And all these abilities have enabled humans to become highly sophisticated in communication and engagement with the natural world. Other species, particularly plants, use their senses to spread information in their own way. And what are the neighbors up to? Most of us are familiar with the smell of freshly cut grass. The volatiles or chemical substances released by the grass plants, which we associate with that smell, are one way that communicate to other nearby plants that a predator, or in this case the lawnmower, is present, prompting an adjustment in plant defenses. Rather than using auditory cues, plants are use chemical-induced communication. However, plant communication does not end with volatiles. Recently, scientists discovered just how well connected plants are and how efficiently they can send messages to their peers via their roots. Electrical signals, a network of underground fungi and soil microbes. The Nosy Plant Neighborhood Watch was discovered. For example, electrophysiology is a relatively new scientific discipline that studies how electrical signals in and between plants are communicated and interpreted, and with major advances in technology and artificial intelligence, AI, we have seen significant accelerated growth in this area of research in the past few years. Scientists could be on the verge of remarkable discoveries. With recent advances integrating electrical signal communication within and between plants into modern greenhouses to monitor and control crop watering or detect nutritional deficiencies. Scientists achieve this by inserting small electrical probes, similar to acupuncture needles, to test how changes in electrical signals relate to plant performance, such as transporting water, nutrient, and converting light into important sugars. Researchers have even influenced plant behavior by sending electrical signals from mobile phones, making them perform basic responses like opening or closing leaves in a Venus fly trap. Soon we may be able to fully understand the language of our crops. A great deal of plant-to-plant communication happens below ground, facilitated by large fungal networks showing that the wood wide web. This network of fungi connects trees and plants underground, allowing them to share resources like water, nutrients, and information. Through this system, older trees can help younger ones grow, and trees can warn each other about dangers such as pests. It's like an underground internet for trees and plants, helping them support and communicate with each other. The network is extensive, with over 80% of plants believed to be connected, making it one of the oldest communication systems in the world. Just as the internet enables us to connect, share ideas, knowledge, and information that can influence decision making, the Wood Wide Web allows plants to use symbiotic fungi to prepare for environmental changes. However, disturbing the soil through chemicals, deforestation, or climate change can disrupt the communication nodes through affecting water and nutrient cycles in these networks, making plants less informed and connected. Not much research has yet been carried out into the effects of disrupting these networks, but we know that plants' responsive behavior, such as defense responses and gene regulation, can be altered by their fungal network if they are connected to one. So this communication disconnect might make them more vulnerable, making it more difficult to protect and restore ecosystems around the world. There is still a lot scientists have to learn about these highly complex networks. We know it's important to help children learn to read so that they can navigate the world around them. It's just as important as to ensure we do not disconnect plant communication. After all, we depend upon plants for our well-being and survival. And this was from the conversation here under Creative Commons by Sven Batke, Associate Head of Research and Knowledge Exchange, Reader in Plant Science, Edge Hill University on Science Alert. Please leave your comments about this, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.